8.8 Systems of Linear Equations. Objective: graph and solve systems of linear equations. The vocabulary we need to focus on for this lesson are the system of linear equations, which just means two or more linear equations with the same variables x, y. The solution of a linear system is just an ordered pair x, y that is a solution of each equation in the system. So here I have a system of two linear equations, and I need to find a solution x, y in which both equations share. Since y equals 2x minus 4 and y equals negative 3x plus 1, I can take 2x minus 4 and set it equal to negative 3x plus 1. Because by the substitution property, 2x minus 4 equals to y. Negative 3x plus 1 also equals to y. Now I can solve for x. I'm going to add 3x to both sides. Cancel out negative 3x and positive 3x on the right hand side. I'm going to add 2x and 3x to get 5x. And I'm going to add 4 to cancel out negative 4 on the left hand side. So my x would equal to 1. Now I can sub 1 into either of these equations to find my y value. So I'm going to use the first one. Y equals 2, 1 minus 4, and then y equals negative 2. And if you want to try the second one, y equals negative 3, 1 plus 1. This would be negative 3 plus 1. It's still equal to negative 2. So it doesn't matter which one you sub it into, you'll get the same answer. So these two systems share the ordered pair 1, negative 2. So that would be called the solution of a linear system with the ordered pair 1, negative 2. Okay, let's practice another one. Okay, since both of these equations are in slope-intercept form, I can easily set both equations equal to each other. And again, now I'm going to solve for x. Subtract x. So I get 3x on the left-hand side. And I want to cancel out the 2 on the left-hand side by subtracting 2 to both sides. So this becomes 0. And x is 0. And I'm going to choose the easier equation to sub in 0 for x. Y equals 0 plus 2, which is just equals to 2. So my solution is 0, 2. Okay, and the next one. Again, setting these equations equal to each other. Subtract 2x to both sides. And then x equals 3. And then it doesn't really matter which one I choose, so I'm just going to choose the second one. 2, 3 minus 5, y equals 1. So 3, 1 would be my solution of the systems of linear equation, two linear equations. Okay, note, if the graphs of two linear equations have different slopes, there is only one solution. Now I'm going to show you cases when this linear system has no solution. So let's take a look at this example. Y equals negative 2x plus 1 and y equals negative 2x plus 5. I can set it equal to each other and try to solve for x. And watch this. And you end with y equal to 5, but y does not equal to 5. So technically there's no solution. And what can we conclude about this? Let's take a look at the equations here again. What is the slope of the first equation? Negative 2. The second equation is the slope is also negative 2. When the slopes are the same for the system of linear equations, when m1 is equal to m2, okay, recall lesson 8.5, then these two lines don't intersect. Okay, they're parallel to each other. Parallel. They don't. If two lines don't intersect, then they'll never meet at a point, and there's obviously no solution. Okay, and then let's take a look at the next practice problem. I'm going to rewrite this equation in slope-intercept form. So y equals 3x minus 1. Why am I rewriting this in slope-intercept form? Because I want to find out what the slope is. The strategy comes with practice. And you see they have the same slope of 3. Then you can automatically conclude that there is no solution. Because these two lines are parallel to each other and they never intersect at a point. Never. Okay, again, this one. Okay, this one is already in slope-intercept form, so we know negative 4 is the slope. And this one, we just have to use the commutative property and switch negative 4x and positive 5 around. And again, it's also negative 4, the slope. So again, no solution. Okay, I'm going to write slope of line 1 is equal to slope of line 2. So the lines are parallel. Line 1 is parallel to line 2, so no solution. And to show me work, it's either you do it this way or you can write words for me. I don't care. Or you can do it this way and show that you'll end up with a equation that doesn't make sense. Now there's a third case in which you have to solve a linear system with many solutions. Now let's take a look at the first problem. 2x minus y equals negative 3. Okay, I'm just going to leave it as it is. And we're going to get to this one. Negative 4x plus 2y equals 6. Now, I'm going to show you a little trick. I could divide this by the GCF of 2 for all the coefficients. Okay, so 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. Now I'm going to multiply everything by negative 1. So I can make my 2 positive. Negative 1 times negative 2 is 2x. negative 1 times positive y is negative y. Negative 1 times 3 is negative 3. And have you noticed that I just transformed the second equation to the same equation as the first one? And if this happens, we can conclude that these two lines are the same lines on the graph and have many solutions. So all you can just simply write all solution. And if you want to use the algebraic way or the long way, okay, so I can rewrite 2x minus y equals negative 3 and set it to the slope-intercept form. Y equals 2x plus 3. And for the other one, negative 4x plus 2y equals 6. 2y equals 4x plus 6. Y equals 2x plus 3. And it's the same. 2x plus 3 equals 2x plus 3. 0 equals 0. Back in chapter 2, I asked you to write all solution if this happens. Okay, let's do a little bit more practice. Again, I just want you to use the short way. Don't waste time. Negative 4x plus 4y equals 12. See if you can make this equation equal to the first equation. Again, I can cancel out the 4. So it's negative 1, 4, 1, 3. Okay, so here we got negative x now, negative 1x, or just simply negative x. And see if we can make it all positive by multiplying by negative 1. Distribute the negative 1. Negative 1 times negative x is positive x. Negative 1 times positive y is negative y. Negative 1 times positive 3 is negative 3. Yes, it's the same equation. So again, all solution. And let's take a look at the next one. I'm just going to copy the second equation to save time. Okay, I could rewrite this equation as in the standard form. 3x plus 3y equals 9. And cancel this out by GCF of 3. Okay. Okay, as you can see, this would be x plus y equal to 3. Same equation, so all solution. Okay, let's take a look at a word problem. Shoes. One wall of a shoe store is used to display court shoes and running shoes. So you're going to have two types of shoes. So I'm going to say I can immediately let x equal to court shoes and y equals to running shoes. Now, do you see why I say setting up or defining what your variables are is important? Because later on you're going to get more and more variables, and if you don't set up a plan to solve the word problem, it's going to become very complicated, and you're going to end up not knowing what you're doing. Okay, here you go. There is enough room on the wall for 120 styles of shoes. So this is the total. Based on past sale, the store manager wants to display twice as many running shoes as court shoes. So more running shoes than court shoes. So we know that there are 120 shoes in all, so x plus y equals 120. That's our first equation. And here's our second equation. Twice as many running shoes as court shoes. So x equals to court shoes. And we need, here, let me reverse that. For running shoes, we need twice as many so it would be y equals 2x, because we want the number of running shoes to be 2 times the number of court shoes. Twice as many running shoes as court shoes. Write and solve a linear system to find the number of each type of shoe to display. Okay? Since y equals 2x, I could sub in 2x into y to solve for x. So this would be 3x, 120, x will equal to 40. So now we need it for 40 court shoes. And then I'm going to take y equals 2 times 40, get 80 pairs of running shoes. To double check your answer, you can see that 40 plus 80 equals 120. And that concludes our lesson for 8.8. Okay, now I'm going to use graphs to show you how these systems of equations work when there's one solution, no solution, and all solution. And I took these examples from the front side of your notes. And let's just confirm the solutions. Okay. I'm just going to use this grid here. Okay, now I'm going to first graph this equation. And I know this equation is in slope-intercept form. So 2 is my slope. My intercept is 0, -4. So I'm going to use the slope-intercept form to graph. Okay, so I know my slope is 2 over 1. Okay, and my y-intercept is 0, -4. Okay, positive 2, so I'm going to shift up 2 units, and then positive 1, I'm going to shift right 1 unit, and then I'm going to connect the graphs. Okay, so this graph would be y equals 2x minus 4. Here I'm labeling the graph because I need to draw a second graph. And I don't know which graph is which one. So when I ask you to graph, you'll be required to label the graph using its equation. Okay, and the second one, I got a slope of -3 over 1, y-intercept 0, 1. So here I'm going to go start at 0, 1 and shift -3 units down along the y-axis. So 1, 2, 3, and shift 1 unit to the right. So here, and this point happens to be 1, -2. And let's confirm if that's our solution. Voila! Yes, it's our solution. I just took the solution from the front side of your notes. And you can always sub this point into either of these equations to double check. Let's take a look at the second one. Okay, again, for the first equation, I know my slope is -2. So -2/1. And my y-intercept is 0, 1. So I'm going to plot 0, 1 as my y-intercept. I'm going to shift 2 units down and then 1 unit to the right. And stop at this point and then draw my graph. And again here, for the second graph or equation, my slope is -2, y-intercept 5, 2, 3, 4, 5, 0, 5. Okay, I'm going to shift down 2 units. I'm going to give a blue color. I'm going to shift down 2 units along the y-axis and 1 unit to the right. As you can see, these two graphs are parallel to each other. Okay, this just means parallel. Okay, the symbol. They're never going to cross each other or intersect each other at any point. It's because they have the same slope. And now the case for all solutions. Okay, because my equations are not in slope-intercept form, I'm just going to look for 2 points for each. So I'm going to look for the x and y intercepts. When x is 0, then y is 3. Okay, so 0 minus 3 is -3. And then when y is 0, we have what? 2x equals -3, so x is just -3/2. Okay, and for the second one, when x is 0, y is 3. When y is 0, x is 6/-4, but we can simplify that to become -3/2. You see, we even end up with same points. Okay, so we only need a graph, well, 0, 3, okay, and -3/2, it's equal to -1.5, so that's about here. Okay, so there's 0, 3, -3/2, 0. And then we can connect the dots. And again, I have to plot the same points and the same line. Since these two graphs overlap each other at every single point, then it is said to be that their solution is all solutions. So that's the proof using graphs.